Welcome to another episode of PSDTV's Engineering Talk Show. I'm your host, Alix Paultre, and I've got Afshin Odabi. He's with Linear Technology, and, well, you've got a lot of cute things out here. We were going to talk a little bit about power and power density, right? Welcome to the show, Afshin.
Thank you very much. Thank you for having us. So, yes, about the power and
power density, I mean, it's getting really critical nowadays.
it is very critical. Density, as you can see, some of the boards that I've brought to show to you, the density of the design itself is indicative of the how populated the products and the boards have become. And getting rid of the heat is a major issue.
Right. Now, what about this board? I noticed how you've got heat sinks, you got big bars on here. How much power is this rated for?
So this is an example of an attempt we did about 2.5 years ago, 2 years ago. This board shows a 300 amp design. Well, let's say 300 amp is 12 volt input, 1 to 0.9 volt output at 300 amps. It has 12 micromodule power products in parallel. So this is the technology we could have offered about 2 years ago, in able to get close to 200 amp-ish or so. But since then, we have been able to improve the power dissipation, and as you said, power density, but whatever is not transferred from the power input to the power output turns into heat. So what are we going to do with that? How are we going to get rid of it? How can we make the board smaller, so for higher density designs? So this was an example I just showed you. Let me show you an example of what we do today. This is 380 amp, as a matter of fact, 386 amp design. Is with the PM bus I2C interface, has one micromodule as the brain with the I2C PM bus,
Right.
and the LTM 4650s are the horsepower, basically scalable. So every package is a 50 amps. It's a dual output 25. We can current share into 50 amps. So this board can do 12 volt input, 0.9 volt output with the 386 amp design, again with digital controls. That means you can write the voltage to it, you can read the current from it, and it does have the black box for the NVM for the logging any kind of fault in the system. So the brain basically controls the rest of the circuitry, and the LTM 4650 is used to provide the power. And as I said, scalable means, okay, I don't need 380 amp, fine. You can take devices out and just scale it down. As a matter of fact, scale it up. One other I would like to add to it is the attention we pay to make the design very simple. If the customer needs to power scale up or scale down, you want to go from 50 amp to 20 amp, we have a device pin compatible. You want to go from 20 amp to 16 amp, pin compatible. So we have products within the families, they're all pin compatible. So if the customer decides to start a prototyping with the low power version, and throughout the prototyping finds out, okay, the ASIC needs more power, don't reiterate your board. Just put save a lot of money. Maybe you have to change your output cap for the ripple because the current went up. But this is one of the areas where we are paying a lot of attention to the packaging technology of our products.
Right. Now, I noticed you were saying how you had the digital set up in almost like a master slave. You could replace all of these with digital devices, couldn't you? Or what are the advantages?
That's correct. So what you're saying is, instead of having one digital control micromodule and then standard micromodule as the added power, can we do just all of them with the digitally controlled package? That is the correct statement. Yes, we can. The advantage is, if you have the device with the PM bus, what we call a PSM devices, repeated, that will give you the ultimate accuracy in a readback current, because every channel now is read and stored. This way, with the way we have it with LTM 4650 added to a digital part, it has to speculate. It's calculated. It's not measured, but it's pretty accurate. You talk about plus minus 5 to maybe 10% accuracy difference, but to a lot of customers is sufficient. It would be cheaper, obviously, because you're not repeating a very expensive part of a digital control. But if the customer needs the
Simple digital control, or you can scale it up to more advanced digital control.
Absolutely correct. Yes, that's a summary. Very good.
So, I noticed that you've got this box here. Is this a breakaway of the packaging itself?
That is correct. This is a 3D show of product that I just mentioned to you, LTM4650 was the example. I'll just hold it up here. So you see the silver top cover of the LTM4650. As a matter of fact, we have another part, lower power, LTM4620, uses the same technology packaging, but the integrated heatsink on board. So to show what that means, it's the design itself. We overmold the components on the micromodule. Absolutely. Thank you for doing that. So this would be the inductors inside, the 2-channel dual output. In terms of 4650s, 25 amp and 25 amp. We do have a 8 amp and 8 amp and a 13 amp and 30 amp version of these devices, and 18 amp and 18, all pin compatible. So the heat generated by the inductor and the MOSFETs within the micromodule. We discussed the originally, you said how power density. Okay, sure. Every switcher, every module generates heat because some of the power is not used to the output, is basically dissipated. Now that turns into heat. How do you get rid of that heat efficiently, quickly, evenly? Is the what I think we're good at Linear. So our packaging team has developed a mechanism, for example, having a heat sink integrated within the micromodule. Within the micromodule means the legs of the heat sink are connected to the heat source, the inductors and the FETs, and then we overmold the device itself, the micromodule. And once you do that, you have the whole device with some of the heat dissipated from the bottom to the PCB, and some is going to be from the top. And with a bit of airflow, it drastically helps out with the heat dissipation. What we have found out, to your point, the board's becoming denser and denser. This is another example of a very highly dense product. The PCB area is limited. The customers try to keep it still small. Okay, if you have to dump the heat on a module or any power supply into the PCB, that means you have to have bigger PCB. You have to have more copper, more layers, more expensive. Yes, nowadays customers are asking us, fine, give us a good, more efficient product, which we have, but what can we do with the airflow? What can you offer us to get rid of the heat? So this design, this technology of an integrated heat sink, it helps us with a bit of airflow, or a customer can attach a heat sink, as I've shown here on the top. All those would help out to mitigate the problem of the heat.
And I notice you have a couple here with different shaped heat sinks. You want to talk a little bit more about, like this one, for example?
Thanks for pointing it out. Yes, that's the triple output 10 amp. So within the 15 by 15 millimeter micromodule package in your hand, that has 3 outputs of 10 amps. And the design is different because you have 3 inductors, 3 sets of FETs. So the form of the heatsink is different. Therefore, that's why you see the difference in shape of it. There is another one, since your hands are open, I can add it to it. This is a single output now. This is a single output 20 amp product with the heatsink differently because it has to sit close to the where the heat is generated, the FETs and inductor. So where it could be a hot spot, we try to get it up to the top of the package, as I said, with a bit of airflow, or perhaps having a cold plate on top of the package. It is fantastically efficient in terms of getting rid of the heat. So you can have a lot of power in small design with this packages.
Very nice. Very, very nice. So I notice you have a very thin one here. What's up with this one?
So what you're holding in your hand is a new family within the micromodule power products. We call them the ultra thin. The standard micromodule products are about 4 millimeter, 2.8 millimeter tall. We found out a lot of applications where the backside of the PCB is left alone, not used, because the power components are thick, too big. So we said, okay, how can we help that one out? How can the customer, instead of populating too densely the top side of the PCB, can they use the backside a bit, whereas pretty much sometimes the vacuum is the PCB left alone. So PCIe is one application. The board size is standard. The thickness is thicker boards nowadays. Board-to-board distance has to have a certain standard. You cannot violate that. But the customer said, can we put power on the backside? It's got to be a very thin package. So we developed the ultra-thin with the 1.8 millimeter tall package. These devices are fantastic for backside PCB mounting. They're also great if one wants to put these devices very close to the FPGAs. Because they're so thin, they can share the same heatsink as the FPGA heatsink. So instead of having it outside the room of the FPGA where the heatsink sits on top. They can put it right close to one another, put the heatsink on top of both of them, so there's no slanted of the heatsink. It fits very nicely, so the board becomes smaller. And the one that you had in your hand, this product is a dual output 10 amp. We also have an extremely small package, the 6 1/4 by 6 1/4. This is the one application, one device, ultra thin still, 1.8 millimeter. We have a dual output 2.5 amp. We have a single output 3 amp, and recently we just released the complete power supply packet, power supply for DDR and QDR memory in the same package, triple output for VDDQ, BTT, and a VREF from one device.
Very impressive.
Well, thank you, sir.
So, at this point, you're basically going to now create more family members now to fill out the application spaces. Is there more development that you see with this family, or is it going to be another product family downstream that you're going to hint at? No? Maybe?
Absolutely, yeah. I would hint. Gladly do it. Answer your question, yes. There are more product families coming up. As a matter of fact, the ultra thin is the most recent in terms of the package. We are coming up with the very new packaging style, which even is more efficient in the dissipating heat. And I would have loved to talk to you about it, but give me another month. I would have given you all the information that you need. We are aiming for high power, that's for sure, but we are also aiming at the extremely low power. We are looking at the isolated micromodules. We do have a series of them. We are doing a higher power version of those, higher voltage isolation. We are, because of our quality of our products being accepted in automotive and avionics. So we are proud of what our quality and reliability guys have done, in addition to the design team and, of course, the packaging guys, which I give them a lot of credit for allowing us to create such a great products.
Well, I think that the advance of all of these disruptive technologies, wide bandgap semiconductors, advanced topologies, has really put the focus on how important good packaging is.
Oh, 100%. I've made a lot of enemies here at work, especially amongst the design team. I tell them they have 30% of the credit for a micromodule, and the next 70% goes to the packaging team. These guys put a lot of good power, good design, and then they throw it to the packaging guys, get rid of the heat. So now these guys start the work, and it's amazing what they do. We can design a product within 4 months to 6 months, but we do take about a year and a half to 2 years to qualify it. And temp shock cycle, power cycle, temp shock are the extreme qualification procedure for us before we release a product. Hence why these products are accepted amongst the best of the best in the industry.
Excellent. Well, Afshin, is there anything else about the products or the family you'd like to leave our audience with before we close out the episode?
If I may, just a few words. Since a few years ago, we started maybe 1 or 2 products in one family, step-down converters. Since then, we have over 100 products. We have over 19 families of the micromodule power products. We have, within the family, if anyone starts with an FPGA design, ASIC, GPU, microprocessor design, look to our products. We have, for every aspect of the design, we have a solution. And I hope they take a look at us, and I'll be glad to service the customers.
Excellent. Is there a drill down page, or they just go to linear.com and get what they need?
Good question. Thank you. So linear.com, then / micromodule, MICRO module, just spell it out, and you end up with the page. And we have a brand new brochure, and we also have a brand new brochure for all the FPGA power supply designs, and with the schematics, with the power tree, and we show how the product's a bill of material, and a photo of the board. So it's a real design we have done with the partners. So we'd be glad to be able to help out, and I think it's a good resource.
Excellent. Well, thank you so much again for taking the time to be on the show.
Thank you very much for your time.
Well, and I'd like to thank everybody out there in the audience for taking the time to be with us. We wouldn't be here without you. Tell your friends. This is Alix Paultre for PSDtv. Thanks.